Greetings. So this is an early PAL VIC-20 9-volt 2-pin model, completely stock. I've just opened it up. It's working. Had a bit of a dodgy display, but I tweaked those variable resistors there, and it seems to have come up well pretty much standard. So I've not done anything to this at all. Currently we're sitting at, if we get that torch out of the way, light out of the way, so 9.5 watts, just over 1 amp. We're using DC obviously at the moment. So I'm going to modify the board, upgrade the board, modernise the board to reduce its power consumption, and also to reduce the amount of heat. So you've got your bridge rectifier under here, so 4 diodes, so that generates a lot of heat. You've got your linear regulator here, 9 volts down to 5 volts, generates a bit of heat. You've got your ROMs, CPU, character ROM, your VIC 6561 in this case, and your VIAs or PIAs, I can't remember on the VIC. Versatile interface adapters, 6522s, so they generate a bit of heat as well. Not at the moment. That one's for keyboard and that one's for expansion bus, I guess. So I'm going to work on this. The main difference between this and a NTSC model is obviously the 6561. We've got there's a 6560 in the NTSC model, and we've got this additional chip here in the PAL model that we don't have in the NTSC model. And obviously also the plug socket is different. Otherwise it's almost the same. Anyway, so that's what we're starting off at. 1.06 amps, 9.5 watts, doing nothing. I'm going to just run diagnostics for an hour and then check what the temperature is after an hour as a starting point. So interestingly, didn't like my penultimate cartridge, so I've whacked in Donkey Kong. And yeah, so this is basically what the screen looked like when I first switched it on, so there's still some issue there with the video output. And it sounds like it's crashed. So say 10.5 watts, 1.17 amps. I just want to run it for an hour to get temperatures, and then I'm going to work on fixing it. Let's see. I'll just leave it. I'll leave it for an hour and I'll check the temperatures. Okay, it's been half an hour and actually it's running better. The colours are pretty much look normal. It hasn't crashed. So maybe it just needed to be warmed up. Anyway, so I've had it running for half an hour now. I've switched over to the standard power supply, so I've got 9 volts AC in. So I can't, not sure what the actual current usage is at the moment, so I'll switch over to DC for that. But I just wanted to give the rectifier a proper workout. Nice and warm, warm. Getting warm. Anyway, let's check the temperatures now. Okay, I've muted the game, so it's still running. Check the temperatures. I'm using a Testor 830-T2. Do the job, I guess. So we'll start off with the bridge rectifier. That's coming in at 47.7 degrees. Let's see, linear regulator. 41.2. Okay, let's check the CPU. That's looking like 46. The kernel ROM. Kernel ROM 46. Well, about 50 degrees for basic, even though basic's not being used. 49.7. Let's do the kernel ROM again. 48.8. So about the same. Let's see, character ROM. That's also coming in at about. Should I do it? 46. 46. Min max. Let's do that way. Wrong button again. 45.5 was the max. CPU again. At 45.2. Let's do the VIC. Okay, about 53 maximum. Let's check out the VIAs, the 6522s. First the keyboard one. About 41. And about 41 for that one as well. I noticed these 7.4 LS245s get quite warm as well. Let's see, I don't know how accurate this is going to be. Go over them. About 45 degrees. So I've got some new ones of these, so I'm going to try and swap them out. So that's our baseline. I'll switch over to the 9-volt DC and check what the consumption is. Just checking 43.4. So that's the linear regulator. That's going to go to nothing basically, well, ambient, once I replace that. Check the rectifier again. 48 degrees. So yeah, so that's our starting point. Let's see how we can improve it. Okay, it's the next day. Good morning. So first up, I have removed the linear regulator. So I'll replace that first, but first I will give the board a nice clean. A little bit of corruption there, so give it a good wash. Yeah, bottom's okay, so I'll give it a good wash, good clean. Replace that first, then next I'll replace the electrolytics, and then we'll see how we go. And here we go, all nice and clean. That's looking a bit rough, I don't know what happened there, but the board is nice and clean and ready to proceed. So first up will be replacing that. So here we are, working again. didn't manage to break it. So board's clean. I've cleaned all the chips as well with alcohol. So the only change is, let me turn that off. Only change is we've put in this modern PSU5 from EZSBC.com. The heatsink isn't strictly needed. It's just there to strengthen the board, I believe. That's what I was told. But we could have left that out, really. So I'm going to let this run. I'm going to add heat sinks to, well, I'm not going to add heat sinks there because I'm going to swap those. I'm going to add heat sinks to the VIC and to the ROMs. 6.5, yeah, this CPU is already getting warm. VIC's obviously going to be, yeah, it's already getting warm. So I'll add heat sinks there as well, let it run for half an hour and check the temps. But already we can see, yeah, 9.2 watts, just over 1 amp. So already we're drawing a lot less power just by changing out that linear regulator. Very good. Okay, here we are. It's still working. We've got the heat sinks on. Replaced, oh okay, I'm getting tired of that. Replaced all the electrolytics with new ones, including that one there. Tiny little heatsink on there just to compare it with those other ones. Makes a few degrees difference. I think noticed about 5 degrees difference with the heatsink on. This is 5 degrees cooler. Anyway, so I'm going to, now that I've done that, I'm going to stick the heatsink back onto the rectifier. And the next step, what shall I do? I will replace these with the modern CMOS versions. That's a pretty quick step. Oh, changing the electrolytics, we're still using basically the same amount of power. I thought it reduced slightly when I did it last time, but that might have been when I replaced the ceramic disc capacitors with little MLCC capacitors. So these ones obviously aren't ceramic discs, so I haven't touched them. So maybe that's what caused the slight drop. Anyway, getting there. Okay, rectifier heatsinks back on, and yeah, it's still working. And we've swapped out the original 6522s for these modern 65C22s, CMOS versions, and we're now under an amp. 8.65 watts, 0.96 amps. So that change has dropped us under an amp. Just putting those two in. So next step is I will replace the kernel ROM with an EEPROM, and then character ROM, and then replace these three. And then I think it's pretty much done. Getting there. Okay, so I've had it running for a bit. One thing I've noticed, let me mute that. There we go. Is that the rectifier, even though I've not changed it, we're still using the same power supply, is running a lot cooler. You can see that 33.5 degrees, whereas at the start, if I look at my notes, right at the start, it was running 48 degrees, so it's dropped, 15 degrees. Not sure why. Maybe we've got this switching regulator in, more efficient, so maybe we're not having to pull more as much power through the regulator rectifier, so it runs cooler. I also noticed that there wasn't much heatsink compound when I took this off. So I've put on a lot of heatsink compound, but that is definitely a lot cooler to the touch. Other than that, these CMOS ones are effectively cold. They are room temperature. Let's have a look. This is the cooler one. So you can see that. 27.5 degrees. So it's it's summer here in Australia at the moment, 9 p.m, 10 p.m. So yeah, these are cool to the touch. So that makes a big difference. In general, the heat sinks, probably make about 5 degrees difference, or about 5 degrees cooler. The little mini heat sink here, that's also dropped a few degrees. It's, you know, it's about 2 or 3 degrees cooler than these other ones here. So yeah, so next step is I will replace the kernel ROM with an EEPROM, which runs a lot cooler, so that should also drop the power consumption. And I'll change the character ROM, and then I'll change these ones out. Okay. Here's just a little close-up of the little mini heatsink I've got on it. Doing the job. And that's the VIC there. CPU, basic, kernel, character ROM, and obviously the CMOS. Okay, I think that's enough for tonight. Alright, so instead of replacing the kernel ROM, I've replaced one of the 74 LS245s with a 74 HCT245. So we've got this one with the heatsink, that one by itself, and that one replaced. And I've checked the temperatures, 33.6 degrees on this one versus 45.8, and you can feel it's warmer. So that's made a big difference. And still, power cable out of the way, working perfectly fine so far. We're down to 0.94 amps, 8.47 watts. So yeah, so I'll go and replace those other two next, and then I'll do the kernel ROM, and then I'll do the character ROM. Okay, I've swapped out the kernel ROM for a 27C128 16K, yeah, 16K ROM. So I've got the PAL kernel in, and the Jiffy DOS, the PAL Jiffy DOS version. We are down to 0.72 watts, 0.8 of an amp. It is feeling cooler than it was. Let's see. So 37 degrees, so that is cooler than it was. So next thing will be the character ROM, which I've got here. So I've made up an image with two Commodore 64 and two VIC-20 fonts, just to fill it up, because they're only 2K each. One strange little thing I noticed. It's got a, I don't know if I can show, a pair of resistors in parallel for R12. So calculate it's a 680 ohm and a 1K. In parallel that gives you about 400 ohms. I checked on another board, I think it's a 390 ohm. I measured at 395. So I've got a 390, so I don't know why that's been done, but I might swap that out as well. But I'll do the character ROM first. And here we go. Turn that off. Character ROM is replaced with a 27C128. I still need to do that little parallel resistor job. Anyway, so that's the final form. Could replace the 6502 as well. You need an adapter board, I think, and it's not 100% compatible. So let me just turn that back on, and this is what we're down to. Just under 7 watts, 0.77 amps. What did we start with? Have a look at my paperwork. Let's see, we started at 1.14 amps, 10.27 watts. So just over 3 watts we're saving, plus the temperature change, temperature improvement. reduced temperatures. So yeah, that's not running as hot as it was. Let's just check that. Where's my temperature gauge? Here we go. So the last one, the character ROM, 46 degrees. Okay, let me do this. 35 degrees. So good 10-11 degrees cooler with the modern EEPROM in inverted commas. Yeah. So the only other thing I'm going to do on this one is convert it to S-video. So that involves removing some of these here and rewiring pin 4 and 5. I've got to dig out my documentation how I did that before, but other than that, this is now a nice cool 0.78. Okay, yeah, done. I'm happy with this. One interesting thing though, I will stop and restart. Okay, so on this one, 16K, I've got 16K. The ROM, character ROM's 2K. I'm not sure off the top of my head. Can't remember. But I've got the Commodore 64 font, the Japanese Commodore 64 font, the VIC-20 font, and the Japanese VIC-20 font. So I think this is maybe the Japanese VIC-20 font. I'd have to connect the keyboard up. But when I activate one of the C64 fonts, you can see we've got the double thickness, but the VIC's not too happy about it. Pull that out again. And it's back nice and happy. So for some reason, I'm sure there is a known reason, the VIC does not like, or maybe these early VICs at least, does not like the C64 font. Although I've not tried with an actual C64 character ROM. I thought that was interesting. Anyway, so there we go. That's the end. What else have I done? I don't know if I mentioned I've added in a new switch, much nicer, and I've added in a 2.1mm power socket to bypass the weird AC input socket. So I've done that. So now I just need to do the S-video and then clean up the case. Oops, sorry, didn't mean to put my finger in there. Job done. That's the that's the katakana. This is the Japanese character ROM active for the VIC-20. There we go. I don't know. My katakana is very... Switch it back on. There we go. Yeah. No, that's definitely not anything sensible. Chifufu. Yeah. Fascinating.